Welcome to this explainer. Today, we're diving into something that is literally the heartbeat of modern software development. I want you to picture your software development process not just as writing code, but as a massive, fully automated, high-tech factory. In this factory, your code is the raw material, and your continuous integration and continuous deployment pipeline, your CI/CD pipeline, well, that's your automated assembly line. If you're an IT professional, or maybe you're gearing up to crush the AZ-400 exam, mastering this assembly line is absolutely crucial. We're going to break down exactly how to construct this unbreakable software factory using Azure Pipelines. Let's get right into it. You know the feeling, right? Your code is absolutely flawless on your laptop. But the real challenge, the total chaos, honestly, starts when you try to move that unmanaged, untested code out into the real world. Without a solid system, it's a gamble every single time. And that is exactly where Azure Pipelines swoops in. It's the ultimate solution that lets us confidently take a single line of code from a developer's machine, run it through rigorous automated checks, and deploy it globally without breaking a sweat. So here is the roadmap for our factory tour today. We'll be hitting 5 key areas: connecting your source control, configuring pipeline agents, scaling with multiple jobs, the ultimate testing strategy, and finally, measuring code coverage. Let's kick things off with Section 1, connecting your source control. First things first. Before we can build absolutely anything, we've got to securely lock down where our raw materials, our source code, actually live, and connect it up using YAML files. Now, Azure Pipelines is super flexible here. It supports multiple Git-based systems out of the box, like Azure Repos, GitHub, and Bitbucket Cloud. And honestly, Git-based workflows are the absolute gold standard for CI/CD. Why? Because you can store your pipeline templates centrally, right alongside your code, which lets you enforce really strict branch policies before a single thing merges into your main assembly line. Now, when you make that connection, let's look at GitHub specifically. You generally have 2 main choices. You can use the GitHub app method, or you can use a personal access token, known as a PAT. We strongly recommend the GitHub app method. It is incredibly secure because it operates using the pipeline's own identity rather than relying on a single user's account, and it supports awesome features like GitHub checks. Contrast that with the legacy PAT method. Sure, a PAT gives you granular permissions, but it's tied to an individual's personal identity. Think about it. If that team member leaves the company or if their token just naturally expires, your entire assembly line grinds to a complete halt. Nobody wants that. Moving right along to Section 2, configuring pipeline agents. Okay, so our raw code is flowing in. Now we need workers on the factory floor to actually process it. In Azure Pipelines, these workers are called pipeline agents. And every single agent in your portal comes with what are basically name-value pairs called capabilities. I like to think of these as a worker's resume. You've got system capabilities, which are automatically discovered, things like the OS type or the machine name. Then you have user-defined capabilities. These are custom configurations you manually assign. So if you install a really unique testing tool on a specific agent, you define a capability for it so the pipeline knows, hey, this specific worker has this unique skill. So how do we make sure the right job goes to the exact right worker? Well, we use agent demands. It's exactly what it sounds like. You are demanding that an agent meets certain conditions before it's allowed to run a job. You set these up using 2 simple operators, exists or equals. For example, you might create a demand that a capability called has payment service simply exists on the agent. Or you might need to be way more specific and demand that the capability agent.os absolutely equals Windows NT. This routing logic is a total game changer because it completely eliminates build failures caused by missing dependencies. You are guaranteeing that the job only ever goes to the worker qualified to handle it. All right, let's turn up the dial. Section 3, scaling with multiple jobs. Once your basic factory is up and humming, your organization is going to grow. And when your assembly line suddenly needs to process thousands of tests or deploy to multiple regions all at once, Azure DevOps gives us 3 distinct job execution strategies. Single agent jobs are your standard sequential tasks. Easy enough, but the real magic happens when we start scaling. Multi-configuration jobs let you run the exact same tasks across different environments simultaneously, like testing an app against 4 completely different operating systems at the exact same time. And then there are multi-agent jobs, which are all about divide and conquer. A multi-agent job can take a massive task, like a suite of 1,000 complex tests, and split it across 4 different agents, drastically slashing your total build time. Now, I really want you to remember this number right here, 1,800. Why? Because Azure DevOps generously gives you 1,800 minutes of free parallel jobs every single month on their Microsoft-hosted agents. It's honestly an incredible built-in asset. It lets you freely experiment with and roll out these parallel multi-job strategies to drastically speed up your pipeline, way before you ever have to even think about paying to upgrade to self-hosted agents.
Let's step into the QA department. Section 4, the ultimate testing strategy.
A truly unbreakable pipeline relies on a testing strategy that covers both the inner developer loop, what's happening on the laptop, and the outer DevOps loop. Let's rapidly run through the functional side first. These are the tests that make sure the individual pieces actually behave the way they're supposed to. We start with unit testing for isolated modules. Then integration testing to make sure those isolated pieces play nicely together. We've got functional testing to verify specific features. UI testing using tools like Selenium to automate actual clicks. End-to-end testing to mimic real user journeys from start to finish. And of course, smoke testing. That's your quick initial check just to make sure the core infrastructure has a pulse before you run anything else.
But hey, we definitely can't stop at just functional testing. We also have to evaluate the overall system health, using the heavy lifters, tools like JMeter or Azure load testing. Load testing increases traffic up to a specific threshold. Stress testing takes it even further. It aggressively pushes the system to excessive loads just to see exactly where its breaking points are and how it manages to recover. Performance testing establishes your baseline benchmarks. And then naturally, penetration testing and security testing scan for vulnerabilities and known CVEs, making absolutely sure your software supply chain is locked down tight. And then we have chaos testing. This is where things get really fun. This is where you intentionally introduce simulated failures, like straight up shutting down a database or severing a network connection, just to validate how well your system recovers. But here is the really fascinating detail. For chaos testing to give you any meaningful data at all, it has to be performed while the application is already under load testing. You literally need to see how the system handles a sudden, catastrophic failure while thousands of users are actively trying to use it. It's the ultimate stress test. Finally, we arrive at Section 5, measuring code coverage. Okay, so we've built the factory, we've set up the QA department, but how do we mathematically prove that our tests are actually doing their job? Well, we enter the audit phase by measuring code coverage. This tracks the exact percentage of your source code that gets executed when your automated tests run. For a .NET application, it's a super straightforward 4-step process. Step 1, pull in a tool like Coverlet or OpenCover. Step 2, configure your YAML to actually build the project. Step 3, add specific command line arguments to your test runner to enable that coverage analysis. And Step 4, use a pipeline task to publish those reports directly into Azure DevOps. It literally shines a spotlight on the dark, untested corners of your codebase and gives you crucial visibility into where your testing gaps are. And there you have it, the whole shebang. We've securely connected our raw materials via source control, trained up our agent workers, scaled the factory floor with multi-job parallel processing, implemented a rock-solid QA testing strategy, and audited the entire thing with code coverage. You now have the complete blueprint for an AZ-400 pipeline strategy. The only question left is, are you ready to take these concepts and build your very own unbreakable software factory? Thanks for tuning into this explainer, and happy building.